Sorry girls, a problem with memory. Constant problem at the minute. Anyway, I was doing example 14, and example 14 had said calculate the amount of sodium hydroxide into 50 centimetres cubed of a 2 molar solution. So 2 molar solution again means 2 moles in a litre, but what it's saying to you is how many moles would I have in 250? So it's the same calculation over and over again. This time they're giving the concentration, asking you to go backwards. In example 12, they were telling you the number of moles and asking you to change the concentration. Okay, so again, if we take a look at this one, you can divide by 1,000 and multiply by 250, and then the method never changes. Okay, so you come down to 1, and some people will say, well, it's just easier for me, miss, to see that that's divided by 4. So 2 divided by 4 over here, and I get 0.5 moles. So I have 0.5 moles in 250. And these questions, you can see, girls, now as I'm doing them, they come up in every single topic. So you'll get them in equilibrium, you'll get them in moles, you'll get them in volumetric analysis, you'll get them in volume of gases. They're constantly asking you to go from concentration to moles, from moles to concentration. Example number 15 then. To calculate the concentration from a mass of solute and a volume. Okay, so if I said I had 4.25 grams of NaNO3, so sodium nitrate, in 250 centimetres cubed, and it asks me to calculate the concentration. So again, that word concentration means that I don't want it in grams per 250, I want it in moles per litre. Okay. That's what I want. That's what the word concentration means. So it says calculate the concentration. So there's loads of ways of going about it. At the moment, I have 4.25 in 250. So I could decide, first of all, I'm going to change this side. So to be consistent with my last question, I could go multiply that by 4. So multiply the grams here by 4 to get this side. At least get it in a litre before we start. So that's 4.25 multiplied by 4. So that's 17 grams in a litre. And now I want to change the grams to moles. Okay, so now I'm going to look at this and say, well, 1 mole of my sodium nitrate is equal to 85 grams. Didn't have 85 grams, only have 17 grams. So my usual calculation, 1 divided by 85 and multiplied by 17. And the answer comes out, the answer beside me, and still I don't trust myself that, because I know there's one of these, I think, that I messed up before, and I don't know if I ever changed it. No, it's not that one anyway. So 0.2 moles is what the 17 grams is worth, and that's 0.2 moles now in a litre. How do I know it's in a litre? Well, I changed it to a litre up here, and I changed the grams to moles here. So now I've done what they asked me to do, which was calculate the concentration. Then 16 and 17 are separate calculations. You'll see them in, well, 16 VV, so this is a percentage VV. You'll see it in question 11. You'll see percentage WV in the ethanoic acid one. You'll also see them... where else would you get percentages? That's really, they're the two main places that you'll get them, the two percentages there. VV is normally ethanol and water, so that comes up in that chapter on organics, and WV is normally ethanoic acid, but they can ask for anything. So they're normals, but they could ask for anything that carries a volume. So things that carry volumes, for example, a VV would be your wines, beers, spirits. They would have VVs written on the backs of the packets. Weight per volume then is something that's dissolved in a liquid. So medications, for example, the amount of active ingredient, for example, in an antibiotic would be a weight per volume. So in the one example I gave you, describe how you would make up 300 centimetres cubed of a 30% VV solution of ethanol. So first of all, you have to know what the 30% VV means, okay? The 30% always means the same, whether it be weight per volume or volume per volume. If it's volume per volume, it's 30 centimetres cubed in 100 centimetres cubed. If it's weight per volume, it's 30 grams in 100 centimetres cubed. So that's what you've got. You've got 30 cm cubed in 100 centimetres cubed, and you want 300 centimetres cubed. So now it's the same calculation as above. I don't want 100 centimetres cubed, I want 300. So I multiply this by 3. So to go to here, I multiply this by 3. So I'd have 90 centimetres cubed. So it asked me to describe how I would do that. So I would say to them, I would measure 90 centimetres cubed with a burette, or a graduated cylinder. Oh my God, I've literally forgotten everything now if I've forgotten that. I'd use a graduated cylinder to measure 90 centimetres cubed. I could also say I use pipette or a burette to measure 90 centimetres cubed, and I would add water till I reached 300 centimetres cubed. So that's the method on how I would do it. So that's asking you to describe a piece of equipment. So you would either use a graduated cylinder, a pipette or a burette to measure 90, and you'd make it up into a 300 centimetre cube solution. So you would add 210 centimetres cubed of water, or you would add water until you reach 300 centimetres cubed in a graduated cylinder. And again, they could ask you weight per volume. It's the same thing. It would have been 30 grams and 100, and they might ask you to change the grams to moles, which is something they could do, which is like the example 14. The next one is 17, and it's parts per million. Parts per million normally comes up in water calculations. So in the calculations in water, there's somewhere else parts per million comes up. You probably know it now better as well as me. There's another calculation somewhere where parts per million comes up. The method never changes, okay? So whatever they give you, you need to get it in grams per litre. So if they give you moles, you change your moles to grams and then change your grams up to litres. So grams per litre. And then once you get it from grams per litre, you multiply your answer by 1,000 because there are 1,000 centimetres cubed in the litre. Okay, so you multiply it by 1,000 to get it in parts per million. So the question says molar concentration of oxygen dissolved, and they tell you had 0.003125 moles of oxygen. Okay, so my job is to change these moles into grams. So I say, well, 1 mole of oxygen is 32 grams. Big thing is not to forget that oxygen is O2. I didn't have 1 mole. I had 0.003125 moles. So it's 0.003125 multiplied by 32. So you had 0.01 grams in a litre. Okay, and then that answer, 0.01, is multiplied by 1,000 to get you 10 parts per million. So once you get it in grams per litre, you multiply your answer by 1,000, so you 0.01 by 1,000 to get it in parts per million. And here, for example, if that was 0.003125 moles of water, then I'd be multiplying by 18. If 18 because water weighs 18 grams. If I had a mole of it. If that was CH4, it would be 16 because 12 plus 4 is 16. So whatever they give me is what the molecular mass is, and I'm changing it to grams per litre. Those parts per million questions, then you will see them at the back of water questions, etc. But I'll ask you now to take a look at them, watch the video, go back through what you did. So go back at your questions, because that's the big thing. What mistake did you make? What did you think they meant when they said concentration? So when I say to you, what does concentration mean? You are all able to say moles per litre. But when you're in the thick of answering a question, sometimes you skip over the word concentration. And I say you, I mean every student does that. So you need to go back and look at your question, see what you actually did, and then come back to me and say, Miss, I'm still struggling with 16 and 17. Can you find me other questions on those ones? And I'll write you a few questions out. Okay? Or you can come back and say to me, actually, I'm fine. Yeah, those ones are easy enough. Normally, I'll have 1 or 2 students who will have difficulty with them, and I'll sort those individuals out, and then we'll take a look at the remainder ones. Okay, so the next ones then are more to do with titrations. So 16, 17, 18, 16, or from 18 onwards, they're titration questions, and we'll go back and take another look at them. And I've written them in such a way that I would normally have used the formula, but I'll go and use the new method or the formula, one of each here, there and everywhere, so you get to see them. Okay, best of luck. Let me know then if there's one of those that you need a little bit more help with, and I can help you with that one. Okay.